All right, here we go. Completing the square. So we'll do a little background knowledge first on how to, a few other things that tie into completing the square. So we've been looking at factoring. This is an algebra tile model of factoring. So if you notice here, it's x squared minus 4x minus 5. We do have some other techniques that we can use if you're, depending where you're at in your learning. This is a simple trinomial, so you can use some of the simple techniques to factor this. This is a little bit more of a longer explanation just to give some background. So I have to take all of these pieces that I have here and make a rectangle. That's my challenge. So if I take my x squared and I move my negative x's around the side here, I'm trying to make a rectangle. And then if I take my ones and fill them in, I get really close to making a rectangle, but I have this one left over. So I need to do some change or make some changes. So I'm going to actually stretch all of these out into one row. I'm going to take these x's and rotate them and put them up on the side. So they're still negative x's, although they broke apart. Okay, and now you can see I have one gap here. There's one more red negative x needed, and I need something along the bottom here. So what I'm going to introduce is actually a zero pair. So that means a positive and a negative. Because those cancel each other out, they're effectively zero. But what they do allow me to do is they allow me to complete or finish the rectangle that I was trying to make. And now once I have a rectangle, now I can bring in the outside or the dimensions. These pieces out here are the dimensions. And the inside is the area. So I've already pre-made one up here. So I have an x and 5 negative 1s. And then on the left side here, I would need another x. So if I'm looking at this, it's x times x is x squared. X times negative 1 is negative x, and I repeat that several times. And then lastly, I need to fill in this location right here. So something times x on the top gives me an x. Well, that something is a positive 1. Okay, and if you look at the dimensions here, on the left-hand side, I have x plus 1. That's this guy. And on the top, I have x minus 5. And those two dimensions are the factors of the original trinomial. Okay, so that's just a quick refresher of factoring. It's finding the area of a rectangle. Okay, so let's get to completing the square. This is a little different. I have the exact same question, except I have positives here instead of negatives, so let me just fix that. The difference being on this one is instead of trying to make a rectangle, I am going to make a square. And that's very important because a square has sides that are the same length. Okay, so they have to be equal. So if I have 4 x's here, 4 negative x's, I'm going to half them. And that's really important because that's part of our algebra steps. I'm going to half them so that they're split up on each side of the x squared term. So I'm going to do this, just like so. And then the whole title here was complete the square. So I'm just going to move these negative 1s over here for now. I'm going to ignore them. I'll deal with them in a minute. So I have to ask myself, what do I need to actually complete this square? So if we start looking at dimensions, x times x gives me an x squared. Now the top x here times something on the side will give me a negative x. Well, I need some negative 1s. So these will be negative 1s on the side. Now I'm going to repeat that on the other side. This x times something on the top gives me a negative x. So I need negative 1s here. Okay, so now you can see I'm starting to get the dimensions of this square that I need. So far it's x minus 2 on the top, x minus 2 on the side, which makes sense because it's a square and they need to be the same dimensions. But the problem is I have this big gap right down here. I have this hole in the problem, and so I need to complete the square. Well, to complete the square, if I look at these pieces here, negative 1 times negative 1, well, if I multiply those together, I get a positive 1. So I get a positive 1. So I need to fill this in. I'm completing the square by putting 4 positive 1s in there. The problem is I can't just introduce 4 positive 1s. They have to come in as 0 pairs. So I also need to introduce 4 negative 1s to keep my original expression balanced. So now what I've done is I've taken this original expression of x squared minus 4x minus 5, and I've changed its form. I've changed its appearance. Okay, and this is what it's going to look like. This box right here. This is x squared minus 4x plus 4. That is going to turn into these two brackets multiplied together. So this is how the pattern is going to look. I started with x squared minus 4x minus 5. I introduced and moved some things around. So I had this. There's the x squared minus 4x. I introduced 4 positives, but I also have to introduce 4 negatives to go with that. And I still have the minus 5 that was from the original. Well, these 3 terms right here, you can see that's this box. And that box can be rewritten as the multiplication of its 2 dimensions, x minus 2 squared. And then lastly, the negative 4 and the negative 5, they combine together, these guys here, they combine together to make a subtracting of 9. So x squared minus 2 all squared minus 9 is just a different algebraic representation of the original we did. Now, we're not always going to draw pictures, so I'm going to show you how to do this algebraically. But a couple of key terms. I halved the x values so that they were on each side of the square. And then you'll notice down here, I am finding the square by finding these 2 dimensions and multiplying them together. And you're going to see that shows up in the algebra. So let's jump in on the algebra. So these are the steps. They get a little bit longer as we move along. I can blow them up a tiny little bit. This is the key piece. A needs to be a 1 before you start. So that is the value in front of the x squared needs to be a 1 before you can start doing this. And if you have to, you will factor the first 2 terms. So this right here is all you need to complete the square. This was the original piece that we put in, the big x squared terms, and these little dudes here, okay, and we had that big gap. So you only need these pieces to actually complete the square. So from there, we're going to find half of the b term and then square it. That's splitting up the b onto both sides and squaring it. We're going to add and subtract that value to the expression. We're always going to write the positive term first. Okay, and then what we should find is the first 3 terms make up a perfect square trinomial, and that's going to allow me to write it as 2 brackets all squared. So this is what it looks like. A is 1. If we look at this example, A is 1. I've accomplished that. I only need the first 2 terms. So what I'm going to do is I'm physically going to move the plus 5 way to the side. I'm not even going to acknowledge it's there. I'm just going to ignore it for now. Okay, so now I want to find half of the b term. Well, the b term in this case is negative 2. So I'm going to go way over to the side here. Here's my negative 2. That's my b term. I want to find half of it. Well, half of that is negative 1. Okay, and then square it. And negative 1 all squared becomes positive 1. Okay, so now what I'm going to do, I'm going to add and subtract that value. So I am going to add 1 and subtract 1 to that expression. These first 3 terms right here should make up a perfect square. Okay, so these guys here, x squared minus 2x plus 1, that is, we have filled in that little missing piece, and we have a perfect square with our algebra tiles, and we can now rewrite it. So what we'll notice, and there's a couple of good reasons I wrote in green on the side here for half the b value, this becomes x something in a bracket all squared. Well, that something comes from the half your b term. So all you have to do is go back up to the right-hand corner here, look up what half the b term is, and that subtracting of 1 goes inside the bracket. These 2 terms here combine, and you are left with plus 4. And so what I've done is I've changed from standard form, this line right here, to what we now will call vertex form, which is also a version of our transformed function x squared. Okay, so that was a fairly straightforward one. I'm going to do one more so we can practice the steps. You'll notice once I got a few extra steps only because it's got a few extra pieces. So we only need the ax squared plus bx. So if we look down here, I have an ax squared plus bx. So I'm looking right down here. Okay, I do need an a value to be 1. So when you look at this one, there's a 2 in front of the x squared. So immediately I have to do some work. I have to factor a 2 and I don't care about the x's. This is really important. I'm factoring out the 2 so that I can just get the x squared term and the x term by itself. So I did not do a common factor of the maximum amount. I'm looking at this, trying to create the ax squared plus bx term that we need to actually complete the square. So there are factoring elements, but it is not decomposition or common factoring like we've done when we're trying to find the factored form. Okay, so you have to understand the whys. It's really important. So we're going to try and find half of the new b term. Well, the b term at the start was 16, but once we factor out the 2, this is my new b term. The 8 is my b term. So if I come off to the side and I take positive 8 and I divide it by 2, I get positive 4. That's half my b term. Then I take 4 and I square it, and I get 16. So I'm going to add 16 and subtract 16. So we've now done find half and then square it. We've done the add and subtract the value, always leading with the positive term first. Super important to do that. The first 3 terms should make up a perfect square trinomial if you've done this correctly. So that means these 3 right here can be represented or rewritten as a bracket all squared. So you know the first term is going to be an x. The next part is half the b term. So come back over here and just read it. Plus 4. Okay, so that's the heavy lifting. Now we just have a little bit of algebra to clean up, and then we're done the problem. Okay, so now you can see there's a 2 that's still sitting out front of the square brackets. I have to deal with it, so I'm going to distributive property and multiply it in. But please be careful, the 2 is only going to multiply into the front. I'm not trying to put it into this red bracket because it's squared. I can't do that. Okay, the 2 will also be multiplied in on the negative 16. So we end up with 2 bracket x plus 4 all squared minus 32. So I've gone from, again, kind of a standard form to a vertex form by doing a couple of steps called completing the square. We'll try one more. This has kind of got everything in it. So again, you only need these first two pieces, the ax squared plus bx pieces, but we do need a equals 1. So when you look at this term here, it has a, b's, and c's, but we don't have an a value as 1. So here we go. We're going to take a line just to push the c term way out of there because we don't actually need it. Then we're going to look at these first 2 terms and say, I don't have an a value of 1, so I'm going to have to factor a 2 out of those terms to get this down to what I need. I keep writing the square brackets and the plus 7. I've now taken care of step number 1. Find half the b term. Well, the b term on this line is 6. This is my b term right here. So b is 6, and it is positive. So half of 6 is positive 3. I square positive 3. Oops, that's really ugly. Let's try that again. 3 squared is 9. So I am going to add 9 and subtract 9. Now the first 3 terms, these ones right here, should make up a perfect square trinomial. So it's going to turn into a bracket squared. X will be the first term, and the next term will be half the b term, plus 3. Okay, so I still have some square brackets to deal with. I still have a 2 and a 9 and a 7 that need a little bit of love. So now we're going to distribute that 2. So the 2 is going to be distributed up front. The 2 will also be distributed to the negative 9. And now it looks like this. 2 bracket x plus 3 all squared minus 18 plus 7. You'll notice the square brackets have been dropped because I've multiplied the 2 in, so I no longer need to keep them. And I'm not going to multiply this 2 into this bracket right here because it's squared. I cannot do that. And then I will just add negative 18 and positive 7 together to get negative 11. And I have changed from standard form to vertex form. And that's completing the square. Where is it handy? Well, if you have a quadratic that looks like this, you can use vertex form to go right to the vertex versus trying to find the x-intercepts, the axis of symmetry, and then the vertex. So something like this question, again, we only need the two middle terms, the ax squared and bx terms, so I'm going to push the 3 off to the side. Half of 6 is 3. 3 squared is 9, so I'm going to add 9 and subtract 9. The first 3 terms here make up the perfect square trinomial. That becomes x plus 3 all squared. And now I add negative 9 and positive 3 together to get negative 6. And I'm in vertex form. And the vertex for this problem would be at negative 3, negative 6. And I'm done. So our goal was to find max and mins by using a factored form approach. That's the dance, the hands out for the x-intercepts, the axis of symmetry, then the vertex. Or we could use something called completing the square and finding vertex form.